Good morning, everybody, and welcome to today's virtual breakfast. For those who don't know me, my name is Jenna Thaler, and I'm a field crops educator up in the Thumb. The collection of demographic data from program participants is an important and mandated aspect of all Michigan State University Extension programming. This is voluntary, and the information that you provide will not be used in any way to identify you personally, but rather as an anonymous member that participated in this program. Please take a moment to answer the questions in the poll that is opening on your screen. Thank you. A couple of housekeeping things. Please mute yourself during the presentations. Make sure you are signed in with your first and your last name. This is particularly important if you're going after those RUP credits today. And to rename yourself if you are not named with your first and last name, click on the participant list icon, find your name and hover over it or click more or rename, and then you can type your name into the window. Throughout the presentations today, please go ahead and ask your questions in the chat box found at the bottom of the screen, and we will get to answering those questions after we get through both Kurt's presentation and Jeff's presentation. This morning, we have Dr. Kurt Steinke talking about Lyme. Kurt, are you ready?
Thanks, Jenna. I think we should be good to go. Let's see here. How's that looking? All right?
Great.
All right. I'd like to thank everybody for joining here this morning. Cool August, feels like September morning. Lots of corn yield estimates coming in across the state, but I was asked a couple months ago to talk about Lyme, and it's a topic that we don't really talk about too much on the virtual breakfast. So I'm going to touch on a few maybe important take-home points about Lyme, items to think about moving into the autumn season. And obviously, I can't cover everything in about 15 minutes or so. So if you do have questions, same for the end, and or always feel free to get a hold of me. Couple of starting points about Lyme. The first, why do we even Lyme acid soils? So there's a number of factors to consider. You can see I got about 12 or 13 listed on the screen. Some of the important ones, again, at those extremely low pH levels, you get those toxic aluminum and manganese concentrations. So when you eliminate that, you can kind of create more base cations, improve root growth, etc. One of the things about pH that we always tend to forget, we think of it as a number, right? And what is the difference between a 6 or 6.5 or a 7? And it's on a log scale, right? So there's about a 10-fold difference for every 1 point difference you see on the pH scale. And the other thing I always remind people of is think of that pH scale as a sliding scale of solubility. When we get into those lower pH soils, your aluminum, your manganese, your iron tends to be a lot more soluble. Your base cations like calcium, your potassium, they tend to be less soluble. And as you go up on that pH scale, your base cations then become a little bit more soluble. And some of these other cations, aluminum, manganese, iron, become a little bit less soluble. The other item to think about with regards to why should we lime some of these acid soils would be you stimulate microbial activity, right? You stimulate the biological activity of that soil. And what does that do? That promotes decomposition of residues, promotes nutrient cycling, etc. From a weed control standpoint, some of your herbicide efficacy can be impacted at some of these low pHs. You start talking about soybean stands, alfalfa stands, your N fixation potential will be impacted at low pH. When you slide up to that 6.5, 7 zone, you get increased availability of a lot of our macronutrients. Over on the right-hand side, you can look at, one of the big ones is improved fertilizer efficiency. When you go from a pH that's maybe mid-4s, low 5s, up to mid-6.5, you dramatically increase the efficiency of what you apply. Improve crop yield, improve longevity of forage stands. And that last one down there, I always throw in there, it's probably one of those topics of soil health that doesn't get enough discussion. You can actually prevent nutrient depletion or excess nutrient accumulation by maintaining that soil in that proper pH zone. And where should that be, right? That's always the question. We should add lime to keep soil pH where on your mineral soils, you want to shoot for that 6 to 6.5 zone. On your organic soils, those low fives, 5.2 to 5.5, somewhere in that range. If magnesium is low in your soil test report, we've got options to use maybe dolomitic lime, which has calcium and magnesium. And one of the things, we have to think about with lime, it is a longer term investment. And this becomes tough. Not all of us own ground. There's a lot of ground that gets leased. And so if you start talking about lime, you're in reality talking about a 5 to 10 year investment in that land. And if you're on a year-to-year or maybe a 2-year lease, this does become difficult not knowing whether you're going to own that ground or farm that ground in future years. The other item to think about is soybeans are not corn. And I put that up there simply because crops behave and perform differently, right? So soil acidity will then affect that crop performance a little bit different. So when you look at your N-fixing bacteria, they require pH usually above about 5.4 or 5.5. Our suggestion for some of those systems is lime when that topsoil pH reaches about 5.5 and that subsoil pH reaches about 6. I have a segment listed there where pH does become profitable, and profitability is producer specific. Keep that in mind. In a corn soybean rotation, usually when you get down to about 5.6, that's when liming does become profitable. In an alfalfa corn soybean rotation, when you start to reach about 6, liming becomes profitable because of all the acid that alfalfa can put out. And in a continuous corn rotation, you can probably get that pH down to low 5s, maybe 5.2, somewhere around there, before liming really becomes profitable. So one thing we got to keep in mind is for those best results, apply that lime well ahead of planting time, which is why we're doing this discussion today as we head into the fall season. Now, I always get the question, how does my ground become acid over time? So there's a number of options or reasons to think of here. Some of these are natural, okay? It could be based on your parent material, whether it's sandstone or limestone, right? And so you look at your sandy areas, tend to form from a sandstone parent material, which tends to have a lot lower pH. Your limestone parent material has a lot higher pH. Look at rainfall. This is more of an issue with like the eastern U.S. and the western U.S., where we tend to have higher rainfall amounts. We tend to leach more of our base cations out of that soil system. Whereas when you go west, rainfall amounts are not as great, and so we tend to get some of our higher pH soils. And so you can see some of the other factors listed there that are initial or natural causes of acid. Some of those that are focused solely on agriculture would be use of ammonium-based fertilizers. So as we apply anhydrous ammonia, as we apply urea, as we apply ammonium sulfate, 28, etc., as those products nitrify, we naturally form some acidity in the soil. So that leads to pHs dropping slowly over time. We also can leach nitrate out of the root zone. And that can cause acidity to build up too. As we take that kava corn off the land, pods of soybeans, wheat grains, etc., we do remove a lot of our base cations, right? And that also leads to acidity over time. And that last one, nitrogen fixation. Nitrogen fixation does put acid back into the soil. So the next question I often get is, how does lime actually reduce soil acidity, right? And so I'm going to take you through a stepwise process here. This would be an example of ag lime, right? Many lime products work similar. But step one is you get these calcium ions from the ag lime. So remember, ag lime's calcium carbonate. They tend to replace aluminum at some of those exchange sites. So lime supplies a surplus of base cations, typically calcium and or magnesium, depending what lime product you use. And it's typically either in a carbonate, hydroxide, or an oxide form. As that material begins to dissolve, that carbonate, hydroxide, or oxide tend to react with hydrogen that's in the soil solution, forms carbonic acid, which then eventually forms water. As a lot of that hydrogen becomes neutralized, you do form some free aluminum, and that free aluminum then reacts with water and forms insoluble compounds, right? So you can see in step two right there, you go from soluble aluminum to insoluble aluminum, and that begins to draw some of that reserve acidity out of that system. And then step 3 down there towards the bottom, you get those carbonate ions from that ag lime, neutralize a lot of the acidity produced, and then that calcium or magnesium then can replace some of the hydrogen and or aluminum on some of those exchange sites. And so the key here is that point at the bottom is that the pH increases over time because your acidity source has been reduced. And so this is one key take-home point here, is there's a lot of misinformation out there that any product with calcium will affect pH, and that's not necessarily true. Every spring, I get the phone call, the emails about ag lime and gypsum and how they perform similarly. Gypsum does have calcium, but gypsum will not neutralize the acidity source like you see at the bottom down there. And so any legitimate liming material works in a similar fashion, right? Whether it's a carbonated form, hydroxide form, or oxide form, you can see a couple of the examples I listed there. There's a lot of materials out there from some of our industrial waste processes. Look at steel mill slags, coal fly ash, beet lime, water treatment product. A lot of them perform similarly. Some of these neutralizing values, which I'll get into here in a second, can be high, but some of those materials, keep in mind, can be very difficult to spread. Lime quality, right? That's what we refer to as the effective calcium carbonate, or ECC. That depends on 2 factors, your purity and your fineness, right? And purity is basically how much calcium carbonate is in this specific product, right? That's what that product is evaluated on, the ability to neutralize soil acid. Something that's 100% calcium carbonate would have a calcium carbonate effective of 100%. So that number tends to go down with impurities. That number tends to go up the more magnesium we have in that specific product. And we tend to use a base of 3 years to evaluate the complete neutralizing ability of these products. So I listed in this table here some specific lime substances that are often used. You can see the neutralizing values listed there. Remember that ag lime is based on a neutralizing value of 90%. So if you have a product that is above 90%, it can neutralize or be more effective at neutralizing more acid. And so you can get away with using a little bit less of that product because it is a little bit more powerful. If it's below 90%, you're going to have to use a little bit more of that product than you would otherwise have to use with your conventional ag lime. The other factor when you consider lime quality, we've talked a little bit about lime purity, would be the effectiveness or the size effect. And so that part deals with the fineness of that particle of lime, right? And so you can look at the little picture I have over on the right-hand side. You can see the finer the grade of that material, the more uniform of a spread pattern that you get. And this becomes an issue because when you think about it, the neutralizing effect of a particle of lime only extends out maybe 1/8 of an inch, maybe 1/4 of an inch from each individual particle of lime. And so the finer the particle is, the better distribution you get, and the more uniform you get the spread, and the more uniform you can neutralize some of that soil acidity over time. Now, Michigan does have a lime law. A lot of states do have a lime law, and that law requires reporting the percent of lime passing through an 8, 60, and 100 mesh sieve, right? And so you might be thinking to yourself, what the heck is that? What is an 8 and 60 and 100 mesh sieve? So you think of a 100 mesh sieve would have basically 100 openings in an inch. A 60 mesh sieve would have 60 openings in an inch, and an 8 mesh sieve would have 8 openings in an inch, right? And so the higher that number, the more fine that product tends to be. And so the Michigan lime law requires a neutralizing value of 80% or higher. 85% of these products must go through an 8 mesh sieve, and 25% of that product must pass through a 100 mesh sieve. And so those lime particles that pass through a 60 mesh sieve are considered 100% effective. If they don't go through an 8 mesh sieve, so they're retained, they would be 0% effective. And between an 8 and a 60 mesh, we consider those 50% effective. And so you can kind of do the math. I threw some numbers down there at the bottom of the screen. If something 5% would be retained on an 8 mesh, 40% on a 60 mesh, and 55% pass through, you could calculate about a 75% fineness factor. And different states have different fineness factors and different lime laws. So Michigan and Indiana are fairly similar. You can see up at the top of the screen there, we have the 8 to 60, and 60 mesh sieve sizes. But if you go down about 4 lines, Ohio is a little bit different. And so living in the tri-state region, you really have to look at that lime label because we live in an area where you might get a lime product that could be from Indiana, Michigan, or Ohio. And you have to look at what those sieve sizes are on that lime label on the back of that lime bag. And this is what those lime sizes might look like. So a 60 mesh sieve over on the left, very fine powder, can become a little bit more difficult to spread. That 8 to 60 mesh, about 50% effective in the middle there, and less than 8 mesh becomes a very coarse product that in some cases can be easier to spread but will not be as effective. And the effectiveness that you see with this particle size over time, look at the graph on the screen. You can look at how pH changes over time. For instance, a 100 mesh sieve, you would get a lot of that to react very quickly in that soil system. And then the coarser that particle size, the longer it would take to react. In some cases, we're getting 2 to 3 years out for all that lime to react completely. So as I wrap up here, a couple things to consider. What is a lime suspension, right? A lime suspension, I get this question all the time. It's nothing more than suspending lime in fluid. We often refer to this as fluid lime, liquid lime. It's usually about 100 mesh or finer, similar in that 60 to 70% range. There's really nothing special about a lime suspension. Advantages, you get that finer particle size for mixing, can react a little bit quicker than some of the granular products out there, can be mixed with other nutrients. You get few dust problems, pretty uniform application. We often see this applied to lease land. Disadvantages would be you likely have to apply something like this annually. We don't get large pH changes because there's only small applications we can put out with a liquid lime application. The last thing, pelletized lime. I get this question a lot. What is pelletized lime? It's calcitic or dolomitic lime, and it's dust that gets pressed into pellets, right? It's very, very fine particle size. Some of those particle sizes can pass a 200 mesh screen, and then they get pressed into these pellets. Nothing special about pelletized lime. Chemically reacts very similar to ag lime. Advantages is can be very high quality, can be blended with other fertilizers, can be banded, broadcast, etc. Disadvantages, it does tend to cost a little bit more money, so a little bit more expensive than ag lime. At similar rates, pH does not change any quicker than conventional ag lime, and that liming effect does get localized around a pellet. So a couple of take-home points as we wrap up. Lime application guidelines in general. You want to try to apply lime at least 6 months before planting the next crop, right? So we're heading into August, 6 months from now, or excuse me, we're heading into September, 6 months from now. You start thinking about that February, March time period, right? So now as we get into the autumn season, great time to do it. Your max application rate in one growing season is usually around 6 tons to the acre. Your max rate for a single application is about 4 tons to the acre. If you do have to go above 4 tons to the acre, we often recommend splitting that application into 2. And point number 5 down there at the bottom, I will caution everyone, heading into soybeans next year, especially on your sandier ground, be very careful of your lime application rate. Heading into soybeans is oftentimes the number one whoopsie or issue we see with lime application, and we see yellowing of those beans heading into that then spring or summer season. So with that, I will wrap up. I'll hand it over to Jeff. I will stick around here a little bit this morning to answer any questions. Thank you, everyone.
Well, thank you, Kurt. And with that, I'll transition and introduce next week's virtual breakfast speaker on next Thursday morning, the 29th. And that's our Dennis Pennington, our MSU wheat specialist. And Dennis is going to be with us to talk as we certainly think about changing seasons here and fall planting, going to be talking about maximizing wheat yields. So that's next week on the 29th. Also want to bring your attention to another event here, in Soybean Harvest Field Day coming up in late September. And I'm going to hand it over to Eric to talk about that.
Thanks, Jeff. Eric Anderson, Michigan soybean extension educator since the spring when Mike Staten retired. Mike has done this soybean harvest field day pretty much ever since this soybean on-farm research program began. This little map here kind of shows where it's been in the past. This year it's going to be down in Lenawee County in the southeast part of the state. I just wanted to alert everyone's attention to, if you've never been to one of these, very interesting. It's a good opportunity to see different manufacturers' equipment out there, different kinds of heads, and it's always free. The sponsors that you see their logos down here are providing lunch for everyone. This year we're going to try something different. Some people have been talking about desiccating soybeans to try to make soybean harvest a little more efficient, maybe even speed things up a little bit. And so we're going to try that. Unfortunately, it looks like just because of the warmness that Jeff has talked about and a little bit of dry conditions down in the southeast, those soybeans are really advanced. And so we're hoping to do the demonstration actually that day. It looks like we may have to desiccate early, and if that is the case, then I'm going to get some video, and we'll still show you what that was like. And Christy Sprague will also be on site to talk about desiccation and a little bit of what she's been doing with her research. But the registration is going to close about a week or so ahead of time. So the QR code in the upper right-hand corner, you can scan that. I also just dropped the link into the chat box. You can follow that. For those of you who are on your phone, you can just do a Google search for Michigan soybean harvest equipment field day and be sure to put in 2024, and it should take you right to that.
All right, we're gonna keep this pretty fast. That way we can get to some of the questions for Kurt before he leaves. Thank you for attending. These are all of our socials you can find us on. And this will be posted there. All righty. We will get into the questions now for Dr. Steinke. The first one we have is, does lime play any part in improving the CEC?
That's a great question. So a lot of that has to do with the mineralogy of whatever field or soil you're on, right? So you got to find out if you're more of a 1-to-1 or 2-to-1 clay, because some of those have more variable charge and permanent charge. So I'm not going to get into the nuts and bolts of that, but typically the more 1-to-1 clays we have, the less influence slight changes in pH will have on that overall CEC. Now, just for reference, remember that most of Michigan has 1-to-1 and 2-to-1 clays mixed throughout. We don't have distinct pockets nearly as much as you go to maybe Minnesota, North Dakota, South Dakota out there. You get these distinct regions of solely 1-to-1 or 2-to-1 clays. We don't necessarily have that here in Michigan.
All righty. Is lime effective in a no-till situation when it is not mixed into the soil?
Another great question. Absolutely. So typically in no-till situations, if you can apply lime every year, we tend to recommend about a half ton to a ton every year. If you can apply lime every year, then we tend to recommend maybe upwards of a ton to 2 tons every 2 or 3 years. And yes, when you surface apply lime, it will take longer, but as that lime begins to dissolve and rainfall moves that lime further and deeper into the soil profile, you will see that liming response take effect, especially in that top 0 to 3 inch zone.
All right. This one you answered in the chat and I put the links, but do you have a good resource for recommended amount of lime to apply on pH and associated buffer pH?
Yep. So if anyone wants to check out soil.msu.edu, you go to resources, go to bulletins. We have our lime bulletin listed up there. A lot of what I went over today is listed on that. We do also have the lime Rex based on pH and buffer pH listed in there for both, I think, mineral and organic soils. And a lot of that is also listed in the Tri-State Bulletin too.
Perfect. What is the specific reason for the yellowing of soybeans when recently limed?
That's a great question. You talk about the cation exchange capacity of a specific soil. So oftentimes when you put out something like ag lime, we saturate that those cation exchange sites with calcium, right? And so what happens? It depresses or moves some of these other cations lower in the soil profile. And in those cases, we tend to see magnesium deficiency sneak in. And some of that can dissipate over time, but usually every spring we start getting to this April time period, we see these yellow streaks go through these coarse textured soils, and it oftentimes shows up first on soybeans, but that's typically what we're looking at. We're looking at a magnesium deficiency created by excessive calcium application. And so that's one thing to think about. One of the myths with liming is that some is good, more is better. If your lime recommendation is for 1.8 tons to the acre, but you got a great deal from your co-op down the road for 3 tons, don't apply 3 tons to the acre. You're going to get this yellow striping that shows up through the field.
Perfect. Can you elaborate on why gypsum does not affect pH?
Yep. So gypsum does not affect the soil pH because it can't neutralize the acidity, right? And so it does have calcium, and that can displace some of that aluminum that's on those exchange sites. But once it does that acidity that's in that soil solution cannot be neutralized because there is no carbonate ion, hydroxide, or oxide ion to neutralize the acid created.
Thank you. Do you see any difference in soil pH adjusting between products, i.e. ag lime versus byproducts like beet lime? He's received questions, why does beet lime not adjust my soil pH as much as ag lime or dole lime?
Yep, I think that one came from Bryce. Yes, so there are differences in liming product out there. So kind of what I went over today, you want to look at the neutralizing value of those products, right? I have it listed on the table there. We also have it in those bulletins also. But something like beet lime can be an effective lime source, but the neutralizing value is a little bit less than ag lime, right? And so if it's a little bit less powerful than ag lime, you're going to need a little bit more of it than as compared to something like ag lime. So that's why we have that neutralizing value in there. If something is not as good at neutralizing soil acid, it's going to take a little bit more of that product. And then you have on the flip side, something like dolomite, which is a little bit more effective at neutralizing soil acid. So you will need a little bit less of that product as compared to conventional ag lime.
All right. Oh, Lordy. Do you have time for a couple more yet, Kurt, or no?
Yeah,
I know we're pushing on your time.
If you make them quick.
All right. Can you speak on the use of marl for liming?
Yep. So marl is basically a combination of calcium carbonate, clay, organic matter. It's a substance that can be mined or taken directly from the soil. So it can be an effective liming agent. One of the issues with some of these alternative products is the spreadability becomes very difficult. So they can be very wet, high moisture, very clumpy. And if you can't get a good spread pattern, I can guarantee you what that field's going to look like the following year. You're going to end up with these yellow splotches through that field. We see this oftentimes too. I get reports of, maybe wastewater treatment lime, marl, that are maybe applied with something like a manure slinger spreader, something like that. If you can't get a uniform distribution of that lime product, I can pretty much guarantee you will get this yellow splotchiness through that field as time goes on. And it becomes very difficult to correct over the short term.
With respect to desired pH for alfalfa, it's been suggested a pH of 7 is more desirable than mid-6s. What are your thoughts?
Yeah, I would say try to push that pH a little bit higher than a 6 on alfalfa, simply because, so I put that up there because that's usually the pH that liming then becomes profitable, right, for alfalfa rotations when it starts to hit 6. Now, what you want to aim for is probably a little bit higher, and the reason for that, alfalfa has a very dense root system, right? It sends roots very deep, wide, very dense, and it puts a lot of acid into that soil system. And so you can see pHs drop fairly quickly in an alfalfa rotation. And so you want to bring that pH probably up to that 6, 5, 7 zone because it will drop over the short term with alfalfa in that rotation.
All right, final one for you, Kurt. With so many different solution lines on the market, which one would you recommend?
Oh, I can't recommend any specific one, and my way out here is going to be that depends, right? But it's going to depend on profitability. It depends on your operation, depends on your equipment, depends on what deal you can get. The big thing is look at the neutralizing value of that specific product and then look at the particle size of that product. Because if you can't spread it uniformly, you're going to have issues. Look at the fineness factor of those products. That's why we have the Michigan lime law. You could get something that maybe doesn't react for a number of years or isn't quite as reactive based on the coarser particle size of that product.
All right, thank you. And thank you so much for joining us this morning. I know you have to get running to your next meeting, so we
Thanks,
appreciate it.
Jenna. Thanks, everyone.
Does anybody have any questions for Jeff? I haven't seen any of those dropped in the chat yet this morning. Jeff, apparently you gave everybody all the news they needed.
Well, that's a good thing. We'll take that today.
So we'll go. I'm getting to our other specialists here in a second. Chris or Marty, you seem to be our other specialists on. Do you guys have any updates?
I cut a corn plot yesterday and we got a little bit of corn earworm. I didn't see one corn borer and I saw just a couple of western beans. And that was a sweet corn plot that's planted to attract these sorts of things. So pretty low out there, at least as far as the leps go. Marty probably has something if he's on. It's been a big year for him.
Marty, are you available to talk? I see you're on, but all right. I'm going to go with Marty is currently probably multitasking like a lot of people and doesn't have anything to share with us then. So with that being said, I want to, oh, we have one for you after all, Jeff. We've been seeing very beautiful sunsets and moons. Is there any smoke in our sky?
There has been, but not nearly what we saw last growing season. So yes, and some of that color that you do see is a result of that smoke. There's still unfortunately fires burning in Canada, and but it's just we've seen most of the smoke with those has remained in locations west of here. So yes, we've seen a little bit of it, but not nearly like what we saw last year.
Jeff, how about the Northern Lights? I'm sorry, Jenna. I was
Oh,
gonna.
good call. Yeah, and we've talked about that. There is another likely. Well, there's the likelihood of another solar event that would lead to some more Northern Lights. So, which it's been one of the best years that I can remember in terms of seeing aurora. But we may see another. Hopefully, we may see another event here, and then the other hope is, of course, that it's clear enough to take advantage of it. So next couple of weeks, keep an eye on that. It depends on solar activity and solar eruption or flare where we see the Northern Lights. So we will see hopefully another opportunity as time comes on here.
Jeff, is there a website that you could like look at every day, or one of the weather sites that kind of says that?
There is, and this is an interesting one. It's new, but it's a new direction, something called space weather. And there are a couple of sites, and let me see if I can add those here to but it talks about some of these factors. And again, we're talking about weather, but certainly not what we're normally used to down on the surface. It's actually up above the atmosphere, but I'll try and get a couple of links in there for you.
Jeff, terrific presentation. They want to know if they can see you daily somewhere.
Well, I don't know. That might get a little rough. And actually, I've got teaching conflicts coming up here soon as well. But I appreciate the feedback. It might be stretched a little thin.
They get a role in your class. You'd see him daily.
And we'd love to have you. Yeah, we'd love to have. It's agricultural climatology, so we'd love to have you this fall.
The follow-up question to that from someone else is, can you put the links in the chat for your other weekly presentations? I believe you do one for like vegetable and such.
Oh, yes, and that's on the Canner news update. Those should be. We did have one technical problem this week on Tuesday. We weren't able to record. So those, and just to give it a schedule, but it isn't going to be that much longer because we're getting towards the end of the growing season. But Tuesday, Wednesday, and Thursday, there should be a recording on there. But those are the weeks that were updated operationally here. Well, in the future, we'll have to see if we want to go more than that. But I appreciate the feedback. But right now, Tuesday, Wednesday, Thursday, but that's only going to be for a few more weeks as we move into the fall.
Absolutely. Thank you, Jeff. That is the end of our questions. And Phil would like to talk about evaluation. So Phil?
So Jenna, one of the things that we have not been asking this year is for everyone to evaluate the virtual breakfast series. At the end of the season, when I say the end of the season, which is fast approaching, we'll be finishing September, I think it's the 19th is the last day for virtual breakfast this year. But after harvest, I'm thinking around the 1st of November, expect to see a Qualtrics evaluation in your inbox coming from me that will be asking for your feedback on the virtual breakfast. We use this information in so many different places. It is very helpful. Please take time to fill that out. I would certainly appreciate it. And I'll leave it at that. Thanks, Jenna.
Perfect. Well, I want to thank Jeff, and Kurt's already left, and all of our specialists who joined us here today. And we look forward to seeing you next week when Dennis Pennington is going to be presenting on wheat. Have a great day, everybody.